chamo André Dantas. Boa tarde, pessoal. Meu nome é André Dantas. Estamos aqui para mais um Papo Coletivo. Eu gostaria de agradecer a presença da nossa convidada, professora Susan Krumdieck. O Coletivo é um programa de inovação em mobilidade urbana que foi criado por uma iniciativa da NTU em 2019 e tem o objetivo de promover a inovação na mobilidade urbana, melhorar o transporte público coletivo no Brasil. Nós temos como patrocinador ouro a Mercedes-Benz do Brasil e a Praxio Tecnologia, patrocinador prata a Caio Induscar e patrocinador bronze a Marco Polo. Nós agradecemos imensamente o apoio dessas empresas. Além deles, nós temos os patrocinadores, os parceiros institucionais e de conteúdo. Bom, espero que vocês se divirtam com essa transmissão do Papo Coletivo, que é muito especial. Eu estou aqui em Brasília e a nossa convidada, a professora Susan Krumdieck, está na Nova Zelândia, na cidade de Christchurch. Bom, eu vou começar lembrando a audiência que vocês podem mandar perguntas pelo chat do YouTube e nós vamos repassar as perguntas para a Susan. Então, a partir desse momento, eu vou me direcionar a Susan em inglês, mas as perguntas podem ser, obviamente, enviadas em português para nós. Tá? Hi, Susan. It's great to have you here. It's a pleasure, it's an honor, and it's great to see you once more as good friends as we are. I'll ask you, just to start off, for you to say a few words and say hello to the audience so we can hit it up, okay?
All right. Yes, hello. Andre, very good to see you again. And I hope everyone enjoys the conversation. Andre and I enjoy our conversations, so we hope you will too.
Okay. Well, Susan, the topic of this Papo Coletivo is transition engineering. So, in a nutshell, can you tell us what the heck is transition engineering for the Brazilian audience and also people from around the world?
Okay, well, engineering, I think we can start with that one, means making things work. Yeah, so we always have our requirements, we have our parameters, we have costs we have to manage, we have people we have to manage. So we've got, lots of things and we make stuff work. How do we do that? Well, we apply the fundamentals of science, right? That's the stuff we're taught at university. And we do that by using methods. So there's always a method. And we are very effective at that when we all are speaking the same language. That language is the science and the method. So that's the easy part, the engineering. If you think about fields of engineering where we put something in front of engineering, we could say electronics engineering, making electronics things work, right? Food proper processing engineering, getting whole factories to make the same biscuit 24 hours a day, right? Okay. So transition engineering, you do have to be woke enough to understand that we are at a point of transition in history. The last 100 years have been on a trajectory that involves a lot of new engineering fields, involves a lot of engineers making the world a better place, and a lot of unintended consequences. Now the science is saying, okay, enough of that, continue with the making things better thing, but now we go a different direction in how we do that. Well, in 100 years, you probably won't need transition engineering, But right now you do. In the change between the way we're used to doing things and the way we will be doing things, there's a time of transition. So change, rethinking, redevelopment, understanding and looking at the unintended consequences and making stuff work. So that one word, transition, it doesn't assume how you're going to do it. What it assumes is that we're all going to be speaking the same language. We're all going to know what the science is, and we're all going to be including those issues of change and transition in our work.
Okay, so to make it's quite complex for us from looking from outside. So let's give an example to the audience, Susan, a very simple example so we can understand what you're talking about, please.
Okay. Well, okay, I think maybe we'll start with an analogy. Fair enough? All right.
Okay.
Throughout the history of engineering, we've come up with things, people have come up with things that were great, but they did harm. All right. And when that harm becomes obvious, then as a field, somebody within the field thinks, wait a minute, we could do that different. That person's lonely for a little while, but then they start to develop a method that's straightforward. Everyone can learn it. Not everyone has to be an expert, but everyone is part of why things are getting better. And that best example is safety engineering. If you haven't gone back and looked at the history of safety engineering, you should, because that is what we're talking about. When the benefits of factories that could produce things of quality that people had never been able to have before, in quantities that people had never been able to have before, and the price was just a lot of workers dying in job. No, that's not okay. It was okay for about 50 years. And then one day it wasn't okay. And now we have safety engineering. Some people are experts in safety engineering in a particular context and a different context and a different context. But the method is the same for everyone. And that method is to look at the failures, look at the accidents, look at what went wrong, and think with your brain what went wrong, and then work to change it so that doesn't happen again. And that, okay, I know it's safety engineering, and safety is a very immediate thing, right? A crash happens or it doesn't. A person steps out into the street or they don't. A person puts on their safety belt or they don't. But the whole system in which there's a signal, there is a safety belt, it is known to work, is a whole different world than if we didn't have safety engineering. So this transition engineering, believe me, it's not a very big book. It's not the training takes a few weeks. And just like safety engineering, you're now seeing things differently in your own specialty that you can start to engineer the transition in. So I do have lots of examples of actual transition engineering projects, but since you're all familiar with safety and with natural hazards management and with emergency response management and with waste management and with air pollution management, these are all that type of thing where the system worked great, but it needed to get better, needed to change to a system that wasn't killing people from air pollution in cities. Yeah.
So as you have your book, because you have published a book about transition engineering, why do people have to learn and practice transition engineering? So why do people in your university have to go through these and incorporate those skills related to transition engineering?
Okay, the number one reason is demand. All of the clients for engineering consultancy want something that's not screwing up the world. They want that to be included. Again, the same way they want your engineers to do due diligence on safety and security. They also want something about sustainability. And I think that the other reason why we need transition engineering is because sustainability engineering isn't working. That whatever the methods are that we think we're following, I don't know, try and name them. In one of the chapters of the book, I did a lot of research to try and figure out, okay, if you're an engineer and somebody says, we want the sustainability, and you go to look up, okay, what's the method for that? You know that you might care. You know that you might have sustainable transport in your, in your title, but the method's a bit thin and it's not actually been delivering sustainability. So the main innovation, I would say, one little innovation, is to do the same thing we do with safety and security and waste management. It's to look at the problem and then reduce that. So in transition engineering, we look at what's unsustainable and then how to change that.
So taking from there, so in Brazil, we have this thing called public transport. As you know, it's quite big. And we wonder how it would be possible to overcome the problems that we have right now, that people complain about the service, people complain about the price, and people complain about everything related to public transport. That's the deal. So how do we apply? Is it possible to apply transition engineering to this context, and specifically a place like Brazil?
All right. We did talk a bit about methodology, yeah? Well, when you were here in New Zealand is when we first started inventing the methodology. We didn't really know that's what we were doing. But what we had decided to do was to take on an impossible problem. And it seemed like the more you think about sustainability, the more the problems always do look impossible, right? Just like what you said, it's hopeless. And so through a lot of research and a lot of practice, right? I mean, that's how you innovate things. You innovate when there is no solution. That's when you have to think of something new. And so through a lot of research on how we deal, like just psychologically, how do we deal with something that's impossible? We've actually got a method that works. And I really enjoy taking on people's absolutely impossible problems and working with people who know those solutions, who know those systems. We can actually, it's not like you find one magic solution or something, but you can find entire ways forward through a lot of different steps. You just see a different pathway that's possible. And it's through the methodology of getting out from under the problem. You essentially get stuck in the problem. It is so impossible that all of the capability you have for solving it gets sort of squashed and you only see the problem. So the methodology lets you get unstuck. So yeah, I think we could even take on this problem.
Okay. Well, we're going to go back to that point, the specific point at the end. But before that, let me ask you, how did you get into mechanical engineering at Arizona State University? How is it possible that you're now in New Zealand? Let's go through this journey and tell people your inspiring trajectory, please.
Right. Well, we all think back to when we were in high school, and sometimes there's a parent, pushing, but a lot of us, there's a high school teacher, right? There's someone who says something to you, or you ask the right question and it opens up a whole new idea. When I was in high school, what I was really interested in was archaeology. I grew up in an area that has the ruins of the Anasazi civilization all around. and the First Peoples Nations are also all around, and there's like their ancestors are there and they're there, and I want to understand this, right? So I wasn't actually interested in engineering, but I was really good at math and science. And then a power plant was built near my hometown, which is out, there's nobody there. It's in the middle of the wilderness. And it caused horrible pollution. I mean, we could actually see the rivers dying, and you couldn't see the mountains anymore because of the smog. And I asked my physics teacher, you know, who designs these power plants? Can't they make it so it doesn't destroy our environment here? And he said, that's mechanical engineering. And so I thought, okay, they need to do things better. And luckily, I was probably in such a remote community that nobody except my physics teacher, who wasn't from there, actually knew what mechanical engineering was. And I never had anybody say, oh, girls don't do that, or, you know, you can't really do that, or there's nobody here who does that, you know, just that sort of pushback. So I just signed up for mechanical engineering, and it has lots of interesting stuff. And so I just kept looking for energy. Like, okay, energy actually seems to be our big problem. If we don't get this figured out, then there's a lot of people, like most people don't understand where their energy comes from, or even how they're using it. And the few people who do are they're not paying attention. So that's why I kept going then. I finished my undergrad and did a master's degree then in energy systems engineering, which, okay, to be fair, is almost all about how to use more energy even better.
Yeah.
But my master's thesis, I took feedback control theory and applied it to anthropology, to human system dynamics in the context of the energy system. And that's where I started understanding how it is that engineering fits into the complex dynamic of civilization, and why it actually is our responsibility to make this all work. It can't be just behavior or consumer choice. It's actually us.
Was that the time that you discovered control systems theory? Because control systems theory, when we first met, you kept explaining to me what control systems theory is, and I think it actually made a lot of sense after a while. But can you explain how did it come to your life, control systems theory? Because I think it's a big part of transition engineering, isn't it?
Oh, but I don't want to put anyone off, because I know that of all the engineers out there, not that many of them actually do control theory.
Sure.
Right. So of all the people in the world, the number who actually know control theory is extremely small. Okay.
But what about that example of the airplane? That's a control system,
we
right?
use it all the time. We really do. It's your well, how anything works. So it's a good thing that somebody knows it. But when I was in undergraduate engineering, we of course had to do control theory, and most of my colleagues knew they had to do it. It was one of the things you have to do. But to me, the theory of it, the mathematics, was so beautiful. I just loved it. So I took all of the graduate level courses, and I just it became a philosophy of life. And basically all it says is, look, if you don't have feedback control in a system, that system crashes. So you know, an airplane has a human controller when the pilot is deciding, taking in information about what's going on and making these crucial decisions for everybody, right? So we may not understand control theory, but somebody's in control, so that works. And then when the automatic pilot is going, the automatic pilot system is taking in information, processing that information through electronics and programming and algorithms, and then controlling mechanical things within the plane that keep the plane going the way it's supposed to. So one thing, if you apply this control theory to human systems, what you can see is why some human cultures are actually sustainable. And that, of course, to our people is a mystery, because while we use the word sustainable a lot, it's not actually built into our system. So that for me was, I want to know how to do that. What is it that's not work? What are the signals that are not matching up? What is the feedback that we need? How would we process those signals in order to actually sort of safely fly the plane, as it were?
Well, so you're originally from the US and you end up in New Zealand. How was it? How was that transition?
Well, while I was top of my class in mechanical engineering, and I had this high level of skill in feedback control theory, which is of very high interest for military toys. You need it a lot. There's the way that I wanted to think about things, like transitioning our energy systems to something that isn't a threat to all of our future generations, that was not a category for research funding in the United States. That how can you do this research if there's no one to apply to funding for? I did work on fuel cells. I worked on biofuels, solar, wind. Yeah, I was doing the good energy thing, right? There's bad energy thing, and then there's good energy thing. But I was not seeing how all the people working on those things would ever change the bad thing. So I wanted to somehow break out of that system and have the freedom to just do weird things. To ask, okay, the way that we use fuel in transport, how would you change that? How would you know what's happening? And that's when I saw this advertisement in New Zealand where it looked like you could just work on whatever research you wanted, and they couldn't fire you.
Okay. So you went to New Zealand in 2000, is that right? So it was a big change for you, wasn't it? Was it the first time that you lived overseas?
Well, if you've known any Americans,
yeah,
they do sort of understand that there's a rest of the world. But it's sort of an abstract concept. But I do have to say that probably New Zealand is a closer culture to Colorado and the Western states than New York is, or California, or Florida, or Iowa. So for us, it actually wasn't that hard to move to New Zealand.
Did you struggle with the language though?
Well, there is that. They have a very, very difficult accents here.
But can you remember why and how you start this research into transition engineering?
Basically, we invented by doing, because I really wanted to look at transport as an energy system. In mechanical engineering, when you study energy systems, of course, it's the production of energy and the way that appliances use energy. So your computer, everything that uses energy, and buildings. But nobody had ever looked at like transport itself, not the car. We do that, but the way we're using the energy, and if you think about a building, we ask that. Well, what are you doing in that building? What do you need to do? What's the building for? We ask that when we design the energy system, and nobody seemed to be asking that in transport. So I thought, this looks like good research gap where we don't know. So I went downstairs, which, if you remember, in Canterbury University, changing floors was kind of a thing, you know. There would be this hush. There's a non-civil engineer on the civil floor. I came down and I wandered around and I found Andre Dada, who's in transport engineering, and I start probing him. What about the fuel? What about energy? Because, you know, it's only a few years until there's going to be kind of a big problem with the fuel supply. How do you deal with that? And that's where you're like, we don't do.
That was a big shock to me, yeah. But I can you remember well Silk's project?
Yeah, so our first go at this, because it seemed like we didn't really know why things were the way they were. Like, what would act
to us, like, what's the context of that analysis?
Okay, so the thing we decided to do was to take the existing, okay, and everybody should remember, this was like 2002, 2003. So there wasn't any Google Map. There wasn't any GIS. And so we wanted to take the actual geospatial context of transport, and then so park that. So what's the locations of houses? What's the locations of destinations? And then we wanted to move over here and say, okay, well, how much could people actually do if there wasn't oil? If it's just a question, okay, it's a question nobody asked. And we thought, well, number one, it depends on the geospatial relationships between the origins and destinations. So yeah, in transport engineering, you use that, but it's to make flows are okay. And in energy, it's like, yeah, but those flows are using energy. So we have to understand sort of why the flows, as opposed to just are there flows. So we built, luckily, it was very lucky that I had accepted some students as interns from where were they from? Germany?
Germany.
Yeah, that they were actually sort of architectural land use planner types. And so they built us a 1:100 scale model, this big model on a big tabletop. Yeah, you all can now just Google map it, but in those days there wasn't a way to understand context in that same way. So down to like the houses on the lots and the streets and yeah, that was an amazing job that Silke did. Her name was Silke, and she built this model. And being able to see that, we started to understand this space where nobody had really looked before of accessibility, that you have activities actually is why we travel. And that doesn't have to be by car. And what determines that is the geospatial relationships. And so we took that model of a part of our city, and that we actually did go ask the anthropologists, what makes a community? Like what, what defines it? Because I think our city isn't it, but within a city, what defines a community? And they said a high school. They said school, because school is where people have a center. So we used the high school zone for a part of the city, Burnside, and that's what we made the map of. And then we just sort of mentally walked through, okay, this house, how do they get to the different things they could get to? And could they do that without petrol in a car? And then we started to see that urban form completely differently, because we started to notice how much land is actually dedicated to that to the car, not to production, not to the activity itself, but just to the car, abandoning the car and moving the car and keeping the car separate from everything else. And it's a huge amount of land.
Yeah.
And so then we just started thinking, and the creativity really started going crazy. So just looking at things, looking at just the facts, just what's there, really created a breakthrough.
Okay, but well, that was a tremendous breakthrough, I think. But when I look at your story, I see this crazy adventure in the middle of nowhere in the Pacific. So so you went a step back, I think, to look at the essentials. Tell us about that adventure. When I think about this, I really admire your courage and your persistence in taking that further. Tell us about that.
Okay, well, I got a hint from another century. Okay, when we first came to Christchurch to look it over and see if we were really going to drag our kids to the end of the planet, we visited a museum that was for Ernst Rutherford, so a Nobel Prize winner who got the model of the atom right. So there have been lots of models of the atom, but he was actually right. And he's a New Zealander, and he was doing his research in Christchurch. So he's a big guy here. And so we visited his lab, and on the door of his lab is a sign that he put there more than 100 years ago that said, we have no money, therefore we must think. And I thought, I get that if we just have the freedom to think, that could be worth way more than money. Now, that said, we actually were successful with some research funding. Once we had some ideas we could explain to somebody else. But that journey of sort of going to a place where you have the freedom to think in ways that aren't yet in the books, that aren't yet in a journal paper, that is not detrimental to innovation. I think that's been all right. So one of the big innovations that we actually discovered through just doing something impossible was time travel. And we tried a lot of different time travel methodologies, and sometimes they failed terribly, but we have figured out how to do it now. And so this methodology of time travel, okay, not actually physically time traveling, but going 100 years ago and learning from the way those people figured their thing out. How were they, because they're doing the same activities we are. Not in the same ways, but they're doing the same activities in the same place. And so we go there and we visit and we understand that. And that's one of the first keys to approaching impossible problems, is that you don't work on them. Because you can't, they're impossible. So you work on the same problem in a time where people had already figured it out. And that unlocks your perspective. And that's actually step one of the methodology, is to, okay, just park that horrible problem you've got and stop thinking about it for a bit and go to your same place 100 years ago and just learn about how people were meeting their needs.
And that's what you did when you went to the Rotuma mine. Is that?
Well, I have another area beside. I like to do the same, like transition engineering for anything. So it could be products, it could be electricity. You know, it can be anything. And actually, the the range of projects I've worked on is pretty big. And one of the things that has again helped, since it helps to come to New Zealand, I go and work in other remote communities. And one of the reasons there is because those remote communities, we call them undeveloped, but actually they, in the way they do things, are much more sustainable than us. That you can understand how these mechanisms of sustainability work, and you can help these folks to not get overrun. So there's a fine line between development and you're not sustainable anymore. So I've really been interested in that whole thing of working with remote communities.
Okay, well, talking about remote, we here in Brazil, we have this thing called public transport. We have this innovation program called Coletivo, in which we are trying to develop some kind of innovation. So help me here. So how should I use, or how should I consider the principles of transition engineering to enhance this innovation process as part of this innovation program?
Well, okay, the first rule of transition engineering is that you have to be an expert on the system that is presenting the problem. All right, so you have to learn all about the system. So probably you have that because you know you have all the data, you've done surveys, you have the knowledge of how to make it work, and yet there's some problem that you say, look, there's something about it that's not working. So the second rule is to characterize what the wicked problem is, because a lot of times you can't really even clearly see, and as long as you can't define the problem, you can't work on it. It'll just keep you stuck where you are. So here we've got 2 steps of the methodology there, and then I have worked with people who didn't know the methodology, say hadn't read the book, hadn't taken a class. And you can work them through it as long as they know we're going to be following a process, and I just need you to do the work at each step, because at each step you have to do modelization, you have to get the numbers, make a model, investigate, interrogate. All right, you have to do the engineering. It's not just philosophy. And innovation, while it's prompted by a vacuum where what to do isn't known, it cannot happen without the science and the data and the reality. So we're not, yeah. You have to be the engineer who knows the system, but then learn the methodology, and you work through the problem, work through the methodology, and you end up just seeing things that you can do, that you can see how into the future, that wicked problem, that impossible problem is in the past. Okay. Because there is a way forward. And that's what we're looking for. We're looking to get the problem solving that we actually have locked in, unlocked, so that it can happen. Okay. So my best advice is to just let's sign up a team and get them trained in the transition engineering and get them some coaching through applying the method and see where we get to.
Somehow, Susan, we are doing that without knowing, maybe. Just to let you know, we have this innovation program, and one of the things that we do, we receive applications from startups. So we have just now finished a kind of an incubation program. And there are 2 projects which are coming out, which are quite interesting. One is in your area of expertise. It's called Energia, which means to put air in. And they look at the problem of comfort, temperature in the buses. And so they created a kind of a ventilation system, which is quite cool and costs very little and reduce the consumption of fuel. The other one is a on-demand transportation, a public transportation system based on crowdsourcing. So they are looking at different ideas. We have more coming up, but how do you think this could be applied, expanded to other areas of interest and things that you think are relevant?
Well, those examples you just gave are examples of what we as problem solvers do, right? That's the thing that gets us into engineering in the first place, is we want to think of the solutions, right? We want to solve problems, and we want to think of new things, right? So the new things that you think of are totally dependent on what you thought the problem was, right? And so in general, the type of innovations that we're used to seeing are sort of within a bigger system that's running off a cliff.
Sure.
So if we can unlock that same ideation, the same processes in the context of the whole system changing direction, then you just change the whole flow of history into the way you want to go. So what I'm also pretty sure of is that right now at this transition era that we're in, there are thousands and thousands of people who are already transition engineers. We just don't have that common language, which makes us uber effective. Okay. Right? And that's happened with every engineering field. That, well, think of steam engines, when there was 700 and some manufacturers of steam engines in the UK at one point, 150 years ago. And none of them could use parts with each other, or, because there wasn't the class in thermodynamics. And so once you get the standardized engineering understanding of what everybody's doing, then it really unlocks the potential of those things. It doesn't stop the innovation, it just opens up the possibility for that field to change the world. And so, yeah, I think we've already got thousands and thousands of transition engineers out there. What I would like to do is get us all working on the big problem of the actual transition through our projects.
So of course, taking from there, we are living a very difficult moment here in Brazil. As you know, COVID-19 is hitting us very badly. You in New Zealand have experienced just a little bit of it, and it hasn't hurt much. But here it's hurting quite a lot. And I have a question here from the audience. It's from Eric Nunes, and he asks this: how can transition engineering help public transport in the COVID era?
All right. In the COVID era, I think what we're going to see is that the shock experienced by COVID, or the shock that we all went through, will do a huge amount to change our perspective. So I think, just for myself, disaster management, resilience, planning, these sorts of things are things that didn't see COVID coming. Now they have. And you'll use the methods for hazards, disaster planning to be better at this. And that's fine, because why not? But the bigger picture of what does it look like to actually be on the trajectory that meets the scientific requirements for not putting too much CO2 in the atmosphere. Well, now we know what it looks like. You can see the numbers. Now, the way that we did it wasn't really planned or engineered. So what if it was? What if we didn't just walk into a wall? What if we approached it with so the COVID-19, as with all things, if you can get away from seeing something as a disaster and say, okay, let's get data, let's actually learn from this, then that's got to be better.
Well, Susan, but we're getting data, and it's quite sad. I think we have talked before about this, and the bus companies, for example, they are going into bankruptcy. They were already in a very dramatic situation prior to the crisis, and now they are stuck with the data that is, if you stop the activity system, the transportation system collapses. So it becomes a vicious cycle that goes on and on and on. So I have another question which ties into this. Is from a dear friend called Gabriela Velasco. She asked, how long does it take for this process of transition engineering, process and methodology, to be applied to innovation? In your experience, how long does it take?
Okay, well, I'm an expert at it. And so if I've got the data and I'm working with people who can work through that data, it would probably be a few weeks project, and we'll then have innovations that we can go with and chase down. I just finished teaching a semester-long class to 50 mechanical engineers, and we were doing energy transition engineering, which actually maybe a third of them did transportation as their project. And so we went methodically and carefully through the whole thing. We learned all about the energy systems. And so, 12 weeks. And you might remember that when you have a class of people, you expect good things from a few of them. And then, like, okay, well, you got something, right? for this big bulk. And then the others, well, yeah. And so you've got this sort of bell curve of what you expect. And this class that did energy transition engineering, taking on absolutely hopeless, impossible problems around New Zealand, every one of them came up with something that you could now take to that company, to that community, to that council, to that bus company, and it would be a really good project. And so that,
what you're saying is it doesn't take very long to go through the process and the methodology.
No, it doesn't. And okay, a lot of people who've gotten the book have read it in a weekend. I keep getting these nice emails from people. You've spoiled my weekend. I was going to go do something. I couldn't put the book down. Now can can you come and do a training at my at my work so we can all do this? And can I work on a project now? So we do have coaching where people it's a learned art. It does take some coaching, but I think people can get better at it pretty quickly. And that's the way these corrective engineering fields have always worked. Like, look at how fast safety engineering changed the world. Waste management, one day there's rubbish everywhere, and a couple of years later there isn't. So you just figure stuff out. It makes sense. It spreads like wildfire. So that's sort of, you can become a transition engineer. And like I said, probably what it is for most people who are already knowledgeable about their field and about the problem, is it's kind of like a sense making, a way to now start seeing the possibilities. And that's what my students, these undergrads, have really achieved. They can see the world the way it will be, and they're not stuck in hopelessness anymore, and they're just getting to work on actual projects that then lead toward that world that they, and you know, if we're talking 22-year-olds, well, that's their world. So
okay, well, let me get from there. How difficult was it for you, a woman in mechanical engineering, and then how difficult it is for you, even now? I know a few of the hurdles that you have to go through to become this worldwide expert in this area. I'd like to take some words of wisdom from you on that sense.
How difficult is it? Well, firstly, to all the women out there, don't give up on your ability to think about complex systems in a multidimensional way. Number two, don't give up on the men being able to be taught to do that.
Okay, I get it.
It was working with you, Andre. It was knowing that you know, that we can actually not just give up on the impossible problems, that just finding a way to work through it. And that's a common language that's not really gender-based. If you have a methodology that lets you successfully do these projects. So the difficulty, I simply deal with difficulty. Maybe you get a hint of that, since what I decided to do for was figure out how do you work on impossible problems, right? And so the way that I dealt with that as an academic, because I knew, I mean, just deal with the facts. There isn't a journal of transition engineering. There isn't a way to progress my career by actually doing what society's paying me to do, which is innovate. I have to be incrementally working along in a known field in order to actually further my career. So I am a professor of mechanical engineering. I was the first woman promoted to full professor in engineering at this university. And I did that by publishing a lot of papers and breaking new ground and doing something that's impossible in chemical vapor deposition of high temperature materials on complex shapes. You can publish that in a materials journal.
Talking about publishing, I have a request here from the audience. Can you say the title of the book? Yeah. We're gonna put the link on our website, but can you show the book once more? It's called Transitioning Green by Dr. Susan Krumdieck, is CRC Press.
Yeah. And I actually did a project in coming up with the word transition engineering, because it was clear to me that the word sustainability was one of these impossible problems. You say this thing and you want that thing and you have the intention, you know, to meet your needs without ruining the future. Yeah, we all agree, and yet it's not actually workable. It's not working. And so how do we use words? I engineered the wording. And so if you Google transition engineering, you only get me. Now that will spread. But
you bought the words in Google Ads. I know that. Okay, well, our time is almost up, but I'd like you to take this final moment to maybe make a note of encouragement for two girls that are at home probably watching, Catarina and Valentina, that you know very well. What's in the future for them? They are 13 and 10. What is the prospect? What they should be looking for? And I think that applies to many people as well. So,
okay. Well, there's been this amazing thing that's happened over the last year, the student strike for climate. Yeah. And the young people have found their voice in kind of a new way. And if they were clearly giving a shove to the people who actually right now can be changing the world so that they're okay, then these could be the convergence of things that actually do lead to the future we want to gift to our children, and our grandchildren and our great-grandchildren. So the elements of, like I said, that I think there's transition engineers out there already. We just need to coalesce and have a field and have our language and have our methodology, build the brand, deliver, and then we can change the world. And you put that together with COVID showing us that, look, things change. We didn't think they did. We thought we were on a trajectory of growth forever. And you can't change things. Well, you can change things. All right. And it wasn't a comet hitting, it was us changing our behaviors. All right. And then you have the young people, the children saying, time's up, you know, get onto it. So I think there is hope there in that convergence of these events. An amazing 2020 is here.
Well, Susan, I'd like to thank you so much for being our first international guest in Papo Coletivo. I thank you for being so kind and so sharing with us with so many experiences of yours, and we'll be in touch, and thank you very much. I'll just finalize for the Brazilian audience in Portuguese. And I hope one day you will visit New Zealand, you'll visit Brazil, maybe from your new destination now, which is coming up. But thank you very much, Susan. Okay.
Well, thank you for having me.
Thank you. Ok, pessoal, muito obrigado pela audiência de vocês. Esse foi mais um Papo Coletivo, como parte do programa de inovação da NTU. Uma boa noite e qualquer dúvida entre em contato conosco pelo nosso site www.coletivo.org.br. Obrigado. Okay, Susan, yeah. Great. I think Maria Luisa is gonna turn it off now.